Hi dear students, welcome to the next topic from electrostatics. This is not exactly a topic, but it is an advanced questions or problems we are doing here. Actually, in the last sessions we have learned about the capacitance and combination of capacitance like a series and parallel and mixed combination. So, three different models or three different examples we have seen. For a series, parallel and the mixed combination. Series also we have seen, parallel also we have seen, then we have seen about the mixed combination. So, today we are going to see some advanced questions. Advanced questions in the sense, typically the questions what we have done in the previous class, there is a chance that majority of the students will give a correct answer. But there are certain tricky questions are there. There are only very few group of students will answer such question, and that will actually decide your rank, okay, in the all India examination. So, today we are going to see such type of advanced questions. Definitely you have to thorough with what we have taken on the last session, then only these sessions you will understand in a better way and you can able to do questions. Here this type of models are, it is pretty simple, but once you see some questions you may feel it is difficult. Okay, so it is not so difficult, it is very easy, conceptually it is very easy, but how we are learning, that is important. So, without wasting the times we will start. Write down advanced problems from combination of capacitor, advanced problem from combination of capacitor. This is a topic for today. We are going to see advanced questions. So, there are totally 4 type of questions we will going to see. So, we will write like type 1, type 2, type 3. So, I will directly jump into the question. There is no concept will be there, and based on the concept, based on the problems, we can describe certain concepts to you. That is what we are going to do. So, we will start with type 1. So, you can write type 1. This you will not get it directly from Ncert textbook. You have to refer lots of reference book only, you will get to know this concept, but listen to the class and write the proper notes. Type 1. Type 1 is wired connection. Type 1 is wired connection. Okay. So, I will take an example, so that will be easy for you. Sometimes you may see a questions like this one capacitor, second capacitor and the third capacitor. This is connected like this and this is connected like this, and this point is marking as A and this point is marking as B. This is C and this is C. So, the question is, what is the, you can write the question along with me, what is the equivalent capacitance between, what is the equivalent capacitance between A and B? This is a question here. We need to find out equivalent capacitance. So, we know the formula for a 2 capacitor which are connected in series, C equivalent is equal to C1 C2 divided by C1 plus C2, right. So, we want to know the fundamental. So, this is the fundamental concept. 2 capacitors connected in series, then C equivalent is equal to C1 C2 divided by C1 plus C2. If 2 capacitors are connected in parallel like this, if 2 capacitors are connected in parallel, then C equivalent is equal to C1 plus C2. This is what we have learned in the last class. Series connection means C1 C2 divided by C1 plus C2. If it is in parallel connection means C1 plus C2 directly. So, based on that all these concepts, we are going to see how we can solve this question. So, hope you know this right side part of the stuffs. Okay. Okay. So, I need certain space will be there. So, for that I am clearing this one. So, this is what we have seen in the last class, but I just cleared that. Okay. Now, we will go into see. Now, I have to tell you some points. Any type of questions, okay, this is not only applicable for capacitance. The same kind of model will comes in current electricity. There they will ask what is the equivalent resistance. Here we will ask equivalent capacitance. Series connection of capacitance is C1 C2 divided by C1 plus C2. Parallel connection of capacitance means C1 plus C2. Equivalent resistance will be here, like series connection of resistance means R1 plus R2. Parallel connection of resistance means R1 R2 divided by R1 plus R2, which means the series connection of capacitance and parallel connection of resistance will have the same formula. Okay. So, I am not going to much about current electricity. Hope you already have seen what is the formula of resistance in series connection R1 plus R2 equivalent capacitance. When it is parallel, resistance R1 R2 divided by R1 plus R2. But for us here capacitance is important. In case of series connection, C1 C2 divided by C1 plus C2. In case of parallel connection, C1 plus C2. Now, I will going to dig into this question. If you see something like this one, it is very hard to find what is series and what is parallel. Whenever you see some wired connection, okay, what you want to do, such type of tricky question is like you have to give the number to the junction. Number to the junction means once you go from here, this junction, see this is this junctions you will give it as 1. Then if you move will be here, you can see another junction here. This junction is number 2. Then if you move will be here, you can see another junction, junction number 3. If you move will be here, you can see another junction, junction number 4. So totally 4 junctions will be here. So I am repeating again, if you see some wired connection, some structure, and it's very hard for you to recognize what is series, what is parallel, it's very difficult. In that context, what you want to do means you have to give a number to the junctions 1, 2, 3, 4 like that. Likewise you have to give the number. Then what you want to group it means, you know A is on the left side and B is on the right side. So you will mark it as A will be here and B will be on the other side. Now if you see will be like between A and B, this is the same wire is connected. So A is equal to 1, right, because it is just a wire. Just a wire is connected means both points are same. So A is same as 1. Similarly, right side if you look will be here, your first junction is 4. 4 is same as B. So B and 4 are same. Next, what you have to look will be here, see, once you reach will be here, you can go here, 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 which means 3 is same as 1. If something is connected in between 1 and 3, then it is not same. Here it is same. Why? Because it is just a symbol a wire. Yes, wire is connected between A to 1 and 1 to 3. Both are same because there is no intermediate connection. So A is same as 1 and 1 is same as what called 3. So 3 will come here. Now we look into the right hand side again. So 4 will be here, same 4, 4, 4, 4, 4, 4, 4, 4, 4, 4 is connected with what number? 2. Same wire is connected. So 4 and 2 are same. Okay, you have to mark like this one. After doing like this one, you have to check anything you missed out. 1, 2, 3, 4, 4 junctions are there. 4 numbers are placed. Then we have the edges A and B, that is also added. Now we have to see the capacitance connected. Capacitance are connected between 1 and 2. So 1 is here, 2 is there. So we need to set up a connections for 1 and 2. So now between 1 and 2, one capacitance connected. Okay. So this capacitance connected, I will give a tick mark. So to understand, I already placed there. Between 2 and 3, another capacitance. So 2 will be there, 3 will be there. So another capacitance, 2 and 3 will be there, another capacitor connected. So this also given tick mark. Next one, between 3 and 4, I am connecting, 3 will be here, 4 will be there, another capacitance. Now this is easy for you to see it, right? This is the point on the left side point. This point is called A point and this point is called B point. So now this is a very simple diagram for you. Now you know all this capacitance values given in the question is C. So all the 3 capacitance are connected in parallel connection. How to find C equivalent? C equivalent capacitance is equal to C1 plus C2 plus C3. But here all the C's are same. All the C1, so C plus C, C1 same, C2 same, C3 same. So answer is what? 3C, which means this is nothing but a parallel connection. But If you get a question like this one, you will easily answer. But if you see something like this one, this is just to confuse you with a wired connection. So be careful about such type of connection. You will give a number to the junction, you separate the number. You first place A will be left side and B will be right side. Definitely you have two edges will be here. One edge will be on the left side and the other edge will be on the right side. So two edges can be placed on the two different positions. Once it is placed, you have another numbers like 1, 2, 3, 4. So all the numbers you will arrange it. You will see what is connected with 1, what is connected with 2, what is connected with 3, what is connected with 4. You will mark it and then you will see one capacitor. This is between 1 and 2. You connect between 1 and 2. You will see between 2 and 3. You connect between 2 and 3. Then 3 and 4. So connect between 3 and 4. That's all. Once you do like this, this is like a transformations. You are transforming or you are converting this complicated diagram into a very simple diagram, which will be help you to answer it very quickly. Because if you look into this one, you understand, oh, it's simple. 3 diagrams which are connected in a short way. So C equivalent equal to C1 plus C2 plus C3. You will quickly answer with 3C. So this is a shortcut methods to answer it, giving the number to the junction. So this is a type 1 wired connection. Okay. So good. This is just one model I will describe. We will see one more model. Okay. One more examples we'll see. The same question. I need to repeat the same question. What is C equivalent between A and B? Between A and B, I want to find out the equivalent capacitance. So I'll connect like this, I'll connect like this, I'll connect like this, I'll connect like this, I'll connect like this. So this is A and this is B. So now there is a connections like this. This is what I need to see. So here 1. Okay, what we need to do? We need to give the name to the junction. So I am giving the name will be here 1, no junction, here 2, okay, another junction 3, another junction 4, that's all. So what we want to do? A will be on the left side and B will be on the right side between A and B. So A is same as what 1 and the same wire is connected will be here. So A 1 3 same. So 1 will be here and 3 will be here. B side if you look, nothing is connected, but there is a wire will be here. Okay, B is not connected with any junction, but there is a wire will be there between what 2 and 4. So where should I mark? I don't know where I have to mark. Okay, so 2 and 4 I can mark maybe here 2 comma 4, both are same. So another separate junction. So B is not connected with any wire. So B is static, standalone, but 2 and 4 will be same. Now I will connect a capacitance between 1 and 2. There are two connections will be here. Between 1 and 2, 1 will be here and 2 will be here. There are two capacitance will be here. First capacitor and second capacitor. So this is connected. Both all capacitance value C I have assumed it. Between 2 and 3, where is 2? The 2 will be here, 3 will be here. Another capacitance will be here. What is the value of that capacitance? C. So this connected, this connected, this connected. Between 3 and 4, so 3 will be here and 4 will be here. Another C is connected. So another C is connected. So this also connected. Next one, between 2 and 4, one connections will be here. 2 will be here between 3 and 4. Between 3 and 4 we have connected. Next one, 4 will be here. 4 and B, one connections will be here. So 4 and B, one connections will be here. The last one, 4 and B, junction with the 4 and B, C. Now we need to find the capacitance between these two. Now if you see the diagram, how many things will be here? We can draw it little neatly. So left side we have A will be here. Now I want to consider only A will be here and other sides B will be here. So these 2 points are important for me. And in between there is a 3 parallel connections are there. So we will draw that diagrams with black color, this one, and we have this one, and we have this one. So all the these two are series, parallel, and one more things will be here like this. See. Okay, so these two are what connection? series connection. So all capacitance are C, 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 C. So first two are in series connection. So the rest of the diagram I am drawing will be here. These two are in series connection. So A will be here and B will be here. So we have an intermediate point that is called C by 2. C1, C2 divided by C1 plus C2. Two capacitance are in series. So C1, C2 divided by C1 plus C2. C1, C are same. So C square by 2C is equal to C by 2. So C by 2 for the first one. And below one C, and this again one we have C, then we have another one that is called C. Now between A and B I need to find out. So between A and B I need to find out means all the threes are in what connection? Parallel connection, and that parallel in series with this one. Okay, so hope you have completed these diagrams on your notebook. If else, not pause the video and complete it. I want this space to complete the rest of the part of the questions. Okay, so perfect. Okay, so the capacitance, three capacitance will be there in parallel combination. So we have to find the equivalent, C by 2 plus C plus C. So which is equal to 2C. So C by 2 plus 2C, equivalent will be equal to 4C, and this become 4C plus C, 5C divided by 2. So total is 5C. Now we have A will be here. Now we have B will be here. 5C by 2. This value is 5C by 2. That is in series with the last one will be here. What is that? C. So all the parallel combination. This is the parallel combination. These parallel combination values we have calculated here. So now we have, now these two are in series. So how to find out series? C1, C2 divided by C1 plus C2. So C1, C2 means 5C by 2 into C whole divided by 5C by 2 plus C. How much will come? So this become 5C square, 2 will come to denominator, so 5C plus 2C. So it becomes 7C. So 5C divided by 7 is the answer for the question. 5C divided by 7. I just simplified, just mathematical simplification. So this are 2, this is multiplied with 2 will be here. So this will be getting simplified, and you will get answer is will be equal to 5C. Both the numerator C square and C will be there in the denominator. Both will get cancel it out, and you will get 5C divided by 7 is the answer. This is called wired connection. So in a wired connections you have to give a number in short. Where you will give the number. Whenever you see a junction, you will give a number, then you will get an answer for the questions. Okay, let's move to next type, that is type 2 models. Okay, type 2 model is called infinite network. Whatever we are learning in capacitance is also important in whatever we have learned in capacitance is also important in resistance also. So we'll move to our type number 2, type 2, infinite network. Infinite network. Infinite network. What is called an infinite network? How to solve an infinite network? Let's take an example. So this is one model. Have to draw. Oops. Like this, like this, like this going. Then it's like this, then like this. Infinity. All the capacitance values are C, 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 C. Infinite network A and B. Questions will ask, what is the effective capacitance? What is the effective capacitance between A and B? The difference with the previous one is this is an infinite network. This is sometimes it's also called a ladder network. Okay, don't much confused. Some textbook, some reference book will also use called ladder network, ladder structure. Or here we will call it as an infinite network. How to solve this infinite network means, if you look into will be here, one parallel C, correct? This C, this C. So this combination is actually repeating here. first set, second set, third set. Okay, you have to draw one more lines. Okay, so this is repeating. So this is repeating, same as this one, same as this one, and same as this one. So this is going continuously. How many numbers will be there? 100 numbers or 200 numbers? No, we don't know, right? It is keep on going. It is infinite network. Whenever you see a problem like this one for an infinite network, what you have to do means you have to take one piece which is repeating the same way. So here this piece is keep on repeating. The minimum piece you have to take it. You can take 1 2 3 and this 1 2. So no, the minimum piece, exactly this piece is repeating here, here, here. So first piece you have to take it. I am telling you the method to solve this one. So what you have to do means you have a network, you have to draw A will be here and the first capacitance and B will be here, C, and this one. So first piece alone you will draw, and the second piece means from here onwards this all the part is equivalent to one capacitance, C equivalent. So whenever you are looking from here you will get C equivalent. So the rest of the parts is equal to a C equivalent, because from here itself it's an equivalent value. That equivalent value, because infinite network means it is not ending at some point. Whenever you are looking from here, it's keep on going, it's not ending. After you walk some 50 meters or 200 meters, then after also you are looking, you will get the same feel because it's not ending. So what is the point of looking from here, and what is the difference if you are looking after 50 meters? It's an infinite ladder. So you are looking from here, you can see it is not at all ending, it's like a C. Then you walk for a 50 meters, then again also you are looking, same step. So what is the difference? No difference at all, right? So in that cases, the rest of the thing is equivalent to, it's called C equivalent, C equivalent. So now what we have to do means we have to solve this one. This is what we are going to see. So now if you look into this diagrams, these two are in what connection? Series connections. So we are solving this one. So we have a points are like this one, and this is called C, this is called A and B, and these two are in series connection. Series connection means how we'll solve these two, solved, and we'll get C1 C2 divided by C1 plus C2. So which means C into C equivalent divided by C plus C equivalent. These two are what connection? Parallel connection. Okay, so I want to clear these sides because I need the rest of the space. Okay, so infinite network or ladder network. Okay, so C equivalent. Now I am writing from here, I am looking. So this is my C equivalent. So I am writing C equivalent equal to C plus C into C equivalent. Parallel connection. Parallel connection means C1 plus C2. C equivalent, C plus C equivalent. We'll simplify this. C equivalent equal to C square plus C into C equivalent plus C into C equivalent whole divided by C plus C equivalent. Just I have taken LCM, I multiply C square, C into C equivalent, C into C equivalent whole divided by C plus C equivalent. What I am going to do? I have to solve this one, I have to find out this one. I am multiplying here, we will see. So C into C equivalent, then plus C equivalent square. This multiplied here, and the right hand side C square plus C into C equivalent plus C into C equivalent. One C into C equivalent will get cancelled. Everything taken to left hand side. So it becomes C equivalent square minus C into C equivalent minus C square. Okay. So C plus C into C equivalent divided by C plus C equivalent. Let me see the steps. Ever made any mistakes? So C square, C into C equivalent. So C equivalent will be there, C plus C square. So we'll multiply C equivalent left side and C equivalent square. Okay, that's all. So we need to solve this one, and we need to find out the value of what is called the value of C equivalent. We have to find out. This is a quadratic equations. Okay, quadratic equations. So to find out the quadratic equation, what is the formula? Minus b plus or minus root of b squared minus 4ac by 2a. 9th standard you are studying, 9th or 10th standard you are studying this formula, right? Minus b, will substitute here. What is called minus b? I will use another color so that you will get a difference. So minus with minus it becomes c. plus or minus root of b square. B square means the coefficient of C equivalent. So C square minus 4a, a means its coefficient, 4ac, C means here C square, whole divided by, here it is minus C square. So you have to multiply it with minus. Okay, 4ac, a is 1 and C is minus C square multiplied with 2a. So 2 into a means 1. So we'll simplify C plus or minus. This is become 4c square. So it becomes 5c square divided by 2 into 1. So C square will come. So I can solve this one. C, if I take it outside, 1 plus root 5 divided by 2 is one solution. Another solution, C into 1 minus root 5 divided by 2. First number is positive or the second number is positive? Root 5, root 4 means 2. Root 5 means 2 point something. So this is positive or this is positive? The first one is positive. So capacitance is a positive value. Capacitance should not be a negative value. So second one is wrong. So your answer to the capacitance question is C into 1 plus root 5 divided by 2. Hope you got this one. Okay, so whenever you solve an infinite network, definitely you will come up with a quadratic equation. Sometimes its value will be given 1 microfarad, 2 microfarad, then it is easy. If capacitance is equal to 1 microfarad, then it is 1 square. Then it becomes C. If capacitance is equal to 2, if capacitance is equal to 2 microfarad, then your equation becomes C equal square minus 2CE minus 4 will come. So you have to substitute and you have to simplify this one. So you will get a 2 solution because the this is a second order equation. It's a differential. It is a quadratic equation, second order quadratic. So in the quadratic equations, you will get 2 solutions. So one is a positive value and one is a negative value. So capacitance value will never become a negative value. It is always a positive value. So we are answering with a positive value. That's all. That's all about the cases. So infinite network, we have seen one example. We will see one more example, then we will move forward. Okay. I want you have to do one more question so that it will be thorough. You will never miss if any questions will be coming for Neet or JEE or any other entrance you have going to write. So I want to mark a second questions like this. This is my second problem to you. This is an example of an infinite going to infinity. Here you have to see what part is repeating. I am giving 1 microfarad, 1 microfarad, 2 microfarad, 1 microfarad, 2 microfarad, 1 microfarad, 2 microfarad. The point will be here A and B. So question is, what is the equivalent capacitance between A and B? Whatever we have solved now, the same question, but diagram is changed. What is the equivalent capacitance between A and B? This is what we going to solve it. So what we'll do, what is the steps will be repeating. You see, this is one structure, same structure here, this C with this C, same structure here. So this is going repeating. So the repeated steps, first steps I will keep it like this, 1 and this is 2. So 1 microfarad and 2 microfarad. This is A and this is B. Then it is repeating. What is repeating? C equivalent in EQ ku badala just CE. C equivalent, and this is repeating forever. So whenever you are looking from here, what you can see? C equivalent. Whenever you are looking from here, there also you can see C equivalent. So both C equivalents are same. We have to simplify. This is what is the concept here. Now we will go and simplify this part. So we're going to simplify the concepts, whatever will be given. These two are what connection? Parallel connection, and this is in series. So we'll solve it. So these two are in parallel connection means what you will get. Okay. So this is 1 farad. So 1, I am not repeating microfarad because I know it is microfarad. Okay, and here we have one capacitance, and this is the point A and B. So what is the equivalent capacitance? C equivalent plus 2, because it is what connection? Parallel connections. So we have to see from here C equivalent. So now these two are series connection. We'll solve it. Okay, so I will solve it. We are solving. So C equivalent is equal to C1 C2. So C1 is 1, C2 is this one. So C equivalent plus 2, C1 C2 divided by C1 plus C2, C1 plus C2. We'll simplify this part. So we'll multiply to here. So C equivalent plus C equivalent square plus 2 into C equivalent is equal to C equivalent plus 2. So C equivalent and C equivalent will get cancelled it out. So we'll simplify. C equivalent square plus 2C equivalent minus 2 is equal to 0. As I told before, now we are reached at a point of where we will got a quadratic equation. How many solutions for a quadratic equation? Two quadratic. A quadratic equation will have two solutions. So we'll get two solutions. We'll see which one is positive. That is our answer. And the negative one, we will ignore it. Okay. So I need this space will be here. And okay, this also not required, right? Anyway, we are almost at the last steps. We have to solve this one. So again, minus b plus or minus root of b square minus 4ac by 2a. Okay, so minus b, which means minus 2 minus b. This is the a coefficient, b coefficient, c coefficient. Here this is a, and here this is b, and here this is c. Hope you already know, right, from 9th 10th standard itself. Root of b square means 2 square, 4 minus 4 into a is 1, c is how much? Minus 2 whole divided by 2a, so 2. So minus 2 plus or minus root of 4 into 2 8, so 8 plus 4 12 divided by 2. So there are two solutions will be here. This I can written as 4 into 3, so it become minus 2 plus or minus 2 root 3 whole divided by 2. So all the 2 will get cancelled out. All the 2 will get cancelled out. So one solution is minus 1 plus root 3 divided by 2. Another solution is minus no, there is no 2. 2 will get cancelled out. Okay. So another solution is minus 1 minus root 3. So there are two solutions for this one. So which one is positive? This is positive. This is the answer. This is all over a negative. Capacitance value will not come as a negative value. So this is a wrong answer, and this is the correct answer for this question. Okay. So hope you know we have done two models. These two models may comes for your entrance examination. So be thorough with that. Okay. Practice it. Two models what we have seen. So what we'll do? We'll go into the how many models we need to study. 4 models we need to study, right? So we are going to solve our third model. So write on the third model. Third model is type 3. Type 3, it's called Wheatstone's bridge model. Type 3 is called Wheatstone's bridge model. Type 3, it's called Wheatstone's bridge model. Wheatstone's bridge model. Okay, you know the Wheatstone's bridge model, right? I will explain first the Wheatstone's bridge model. For example, we'll always, as usual, we'll directly go to the questions and we'll say. So we need to find out the equivalent capacitance between A and B. For example, this is 1 microfarad, 1, 2, and this is 3, and this is 6 microfarad. So microfarad, I am really hesitated to do this microfarad because always, okay, laziness. Okay, what to do? We need to correct it, right? Microfarad. Okay, come. So 1 microfarad, 2 microfarad, 3 microfarad, 6 microfarad. Next, and here I missed out. Here I have a 4 microfarad. So what is this Wheatstone's bridge states that? The Wheatstone's bridge you are learning very elaborated part in which chapter? Current electricity. So there what is the main point is like you see one connection will be here left side and you see another connections will be there on the right side. So these connection you have to draw vertically. This is called let me take another color, and this is called C1 and this is called C2 and this is called C3 and this is called C4. You have to check whether C1 is equal, C1 by C2 is equal to C3 by C4. In case of current electricity in where we'll say in Wheatstone's bridge, you may learn like R1 by R2 is equal to R3 by F4. Anyway, but the point is like this ratio left hand side ratio is equal to right hand side ratio. If that is matches, then bus you are answered correctly. That is the meaning. So whenever if such conditions are exist, what is the meaning of this one means this point I am giving like maybe P and this point I am giving as Q. So a capacitor or resistor is active or live whenever there is a current flow. Always remember one point from me which is very crucial in physics. Current will flow always whenever a potential difference are there. Whenever a potential difference are there. I will tell you an example. You have seen there is lot of electrical lines will be there, right? Wherever you go in the roadside or all major area, you can see the electrical lines. Birds are flying and sitting on the electrical line. Whether they get shocked? No. Why they are not get shocked? The two legs are there. Two legs are in the same voltage. Same voltage. Same voltage means what is the potential difference between the two legs which are touched on the line. One line will have 240 voltage. The current which is coming to our house, the voltage which is coming to our house is 240 voltage. If 240 voltage will be there on the both legs of crow or any bird, no potential difference, no current will flow. It is very cool. It will not die. But what will happen if one leg is removed by the bird? Is it get shocked? No, never. If one leg is removed also, the throughout its potential will be equal to 0. Okay. Suppose you are hanging in an electric line. You are just hanging in an electrical line on top. You will get shocked? No. Two hands are hanging. Now you removed one hand and you are holding one line. You will get shocked? No. You can say I am not getting shocked. I am not getting shocked. What will happen? One of your leg is touches on the ground. That's all. You will never remember that moment. Fuse. You will get fused. What will happen? All of that done, finished. What will happen? Your hand is at 240 voltage and your leg is touching on the ground will have how much voltage? 0 voltage. What is the potential difference? 240 volt. 240 minus 0. But whenever your both hands on the electric line, what is the voltage here? 240. What is the voltage will be here? 240. So 240 minus 240. What is the voltage difference? 0. Whenever there is no voltage difference, current will not flow. Current will flow only when there is a voltage difference. So in this case, Wheatstone's bridge structure, if the left hand side ratio is equal to right hand side ratios are there, then the speciality of this one means the potential at P is equal to potential at Q. So this is very important. Potential at P is equal to potential at Q. So this is the conditions for a Wheatstone's bridge. Two conditions. Potential at P is equal to potential at Q. If such conditions are exist, voltage here and voltage here will be same. In the 4 microfarad is a dead capacitor. It has no use. It will not do any job. You can just plainly remove that. So once you remove that, now your equivalent circuit is look like this one. You have top 1 and 3 will be here, 1 and 3 will be here, 1 3, and you have bottom. How many things will be here? You bottom also you have 2 things will be here, right? What things? 2 and 6. Now we have to simplify this one. This is series connection, C1 C2 divided by C1 plus C2. So 1 into 3 divided by 4. This is the first capacitor, and bottom we have the next capacitor. This is B and this is A. 2 into 6 12 divided by 2 plus 6 8. So this become 3 by 4. This become 4 which will cut. So it become 3 by 2. Okay. Now two capacitance 3 by 4 and 3 by 2 both are connected in what fashion? Parallel connection. So we will find the equivalent capacitance. So C equivalent equal to 3 by 4 plus 3 by 2. Take it as 4 as the LCM. So 3 plus here 4 into 2 times 2 into 3 6. So it become 9 by 4. What is the unit? Microfarad. I started with microfarad. I have to end with microfarad. So 9 by 4 microfarad is the capacitance value for the type 3 Wheatstone's bridge model. In model Wheatstone's bridge model. So whenever if the left hand side ratio is equal to right hand side ratio, what will happens? The voltage at the point P is equal to voltage at the point Q. Two voltages at the two different points are same, and if you connected any device between them, nothing will happens. That is a dead device. Okay, so you can just remove it, the 4 microfarad, you can throw to the waste basket. That's all. So only 1 and 3 will be effective, and bottom 2 and 6 will be effective. This is what is actually happening there. Okay, so we will see. What we'll see? We'll see the next model. Of course, a different flavor. Okay, that is also coming within type 3. We'll see a different flavor, different flavor, different flavor, different flavor, different flavor, different flavor. First one, 1, 2 and 3. I connected like this. I connected like this. So this is A and this is B. C, 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 all are C. What is the question? What is the C equivalent between A and B? Equivalent capacitance between A and B. This is a junction diagram. What you will do? You will give a number. So 1, 2, 3, 4. Jolly. Now what we need to do? We need to simplify. A and 1 will be the same. So A will be here and 1 will be here, same. And B and 4 will be same. So B is connected here and 4 is connected here. Another 2 numbers, nobody I cannot connect. So 2. So please place it. 2 will be here and 3 will be here. You can place it in any order. 3 may be upside, 2 will be outside. But make sure that the other 2 numbers which you are not able to connect, it should be distributed between these 2 ends. Now we'll see. Between 1 and 2. See. Between 1 and 2. First capacitance. Between 1 and 2. Capacitance C is connected. Between 2 and 3. The next capacitor is connected. This is connected. Next one, between 4 and 3, next capacitance, 4 and 3, 4 will be here, between 4 and 3, next capacitor. Another one will be there on the top, 1 and 3 is connected, 1 and 3. So 1 will be here and 3 will be here. The bottom also, between 2 and 4. So 2 will be there and 4 will be here. So 2 and 4, next capacitance. This is what structure, boss? Tell me, boss, what is structure? Left hand side ratio C by C, answer is 1, is equal to right hand ratio C by C, answer is 1. Left hand side's ratio is equal to right hand side ratio means you can ignore the which capacitance? You can ignore the middle capacitor going out. So now your circuits will look like this one, A, and you have 2 parts will be here like this and like this and like this, like this, like this, B. The top 2 things C, C, bottom 2 things C, C. 2 capacitance which are connected in series. Top side, what is the capacitance you will get? A. Top side you will get C by 2. 2 capacitance, equal capacitance and series connection. If there are n capacitance connected in series, then what will come? C by n. If there are n equal capacitance are connected in parallel, what you will get? NC. So it's C by 2 will be here and C by 2 will be here. So both are connected with NB, both are parallel, C by 2 plus C by 2. So C equivalent will be equal to C by 2 plus C by 2. Answer is equal to C. Answer equal to C. Okay, so the answer to the question is C. This is a Wheatstone's bridge model. This is a Wheatstone's bridge model. Understood? We'll do another example. You should be thorough with this one. Then only all the type of tricky questions you can able to answer it, so that you will be an hero in the entrance examination. Result will announce, you will become an hero. Okay, so we'll say next question. Next question, A will be here. Next one, 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 all C, 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 C between A and B. Okay, so we need to find out C equivalent between A and B. Between A and B, what is the equivalent capacitance? See, if you look into will be here, this A, instead of connecting here, this A you can also connect it here also, right? Both are same because this is a wire. So you can connect it here also, you can connect it here also, anywhere you can connect it. So there is no mistakes will be here. So this ratio C by C 1, C by C 1, this is what connection, what is available, what is available in the lower half, what is available in the lower half. This is an example, this is a Wheatstone's bridge. This is a Wheatstone's bridge. In Wheatstone's bridge, what we have to check? We have to check the left hand side ratio. C by C 1. So C by C left hand side is equal to right hand side C by C 1. So what you can remove? You can ignore this middle one. You can ignore this. Now we have to redraw the circuit diagram. So we have A will be here and we have a network. And this C and C series connection, we have removed this one. So this become what? Two C's are in series. C in series with C. C1 C2 divided by C1 plus C2. You will get an answer equal to C by 2. Bottom also in series connection. So another one. Okay. So A will be here and B will be here. So 3 are in parallel connection. This C by 2 parallel. What you will get? C by 2 plus C by 2 plus C total capacitance. So C equivalent equal to C plus C by 2 plus C by 2. Answer is 2C. Bus over. Answer is 2C. Now you got an answer to this question for type 3 Wheatstone's bridge model. Your answer is equal to 2C. Hope you got the type 3 models very clearly. Okay, we'll move to our final steps, which is a type 4 models. So write down the heading. Type 4. We're going to see type 4. What type 4 is going to do any magic to us? Of course, it's doing a magic to you. So write type 4. Dun, 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 dun. Type 4 is parallel plate capacitor. Parallel plate capacitor. Don't think about, sir, parallel plate capacitor we have learned. Why you are doing like this? No. That is different. This is different. Okay. Let me take an examples to you. Something like this. Questions will come like this. And they will mark the distance D. And this distance is T. And this distance is T. Then they will give you area of all plate. All plate is equal to A. Find the equivalent capacitance. Equivalent capacitance in the short form I am writing C equivalent between A and B. So you find the C equivalent capacitance between A and B. When you see this kind of model of questions, what you want to remember always, whenever you are connecting between two different metals, this is one metal piece, A is one plate, B is another plate. So a capacitance can form between two different plates, not between same plates. So here I want to, here A will be there and B will be there. How you need to solve this I am telling. So here A will be here and your B will be here. So you see this is A plate. This is A plate. This is also A plate. This is B plate. This is B plate. A, B, different metals will be forming. You will get one capacitance. So one capacitance between available between what and what? A and B. So actually here one capacitance. This is the meaning of this one. B and B. Sorry, this is also A, right? A. So B and A next capacitance will be available, and between A and B next capacitance. So totally how many capacitance will be here? 3 capacitance will be there. A and B, one capacitor. So this is over. B and A next capacitor, B to A next capacitor. So C, all capacitance are C. And between A and B next capacitor. Next capacitor. So see, so this capacitor is over. So three capacitors are exist between A and B. What is the capacitance value of a parallel plate? Epsilon A divided by D. In the previous sessions we have learned about this one, right? C equal to epsilon A by D. Now the capacitance are connected in a what kind of a between A and B? This is what connection? Parallel connection. So C equivalent equal to C plus C plus C. Answer is equal to 3C. Beautiful answer. We have got answers. So this model, whenever you give a the name to the plates, and if you see, of course, that will leads to an equivalent capacitance. Okay, we'll do another model and we'll see whether we are getting the correct answer for this part. Okay, so let me take another model. Okay, slightly different, but yeah, we'll see. Find the equivalent capacitance between A and B. C equivalent between A and B. This is the question. So what you need to do when you get some questions will be you have to give the name to the plate. This plate A and this plate B, this plate again B, this plate again A. Capacitance are exist between different plates. So here one capacitance will be here. Here any capacitance? No. Why? B and B are same. Here one capacitance. Now we will connect to the name called A will be here and B will be here. First capacitance between A and B we have this capacitance. Okay, so we'll draw that capacitance between A and B, C, and here also we have another capacitance B and A, so another capacitance. So this is what connections you got it now, parallel connection. So C equivalent equal to C plus C, C1 plus C2, correct tane? So C1 plus C2 means you will get 2C. It is correct now. So C plus C you will get answer is equal to 2C. So this is a model in which you have to answer. Here there is no capacitance existed between because it's the same plate, but here capacitance are exist between different plates. Okay, that's all. So 4 models we have seen. Hope you understand the 4 different type of advanced questions we have done it from the combination of capacitance. Okay, so bye.